So for the first video of our basic technical knowledge series, I'm going to talk a little bit about projection methods. So what is projection in the first place? Projection is basically projecting a 3D object to a 2D surface. This allows us to implement this 3D object into a 2D plane so we can draw it. So we don't exactly know how to draw on a 3D surface, and we can't view the 3D surface through its all faces at once. So you need to project this 3D surface, 3D object into one or maybe multiple of 2D surfaces so you can understand the object to its fullest. In engineering drawings, that is an obligation. There are different methods of projection, and all of these projection methods are separated into two sections. The first one is the parallel projection, and the second one is the perspective projection. So perspective projection is what we actually do in real life. It's what our eyes are made for. In perspective projection, if you have a point-like source of light, your eye is going to receive that light like it's magnified when it's getting further and further. When it's getting closer and closer. So it creates this effect or illusion or whatever you call it. It creates this effect that distant objects are smaller than the objects that are closer to you. In a sense of drawing, these are made by creating different vanishing points. If you're looking for a one-point perspective, you're going to have one light source, one vanishing point. If you're looking for a 2-point, you're going to have 2 vanishing points, and then 3-point, you're going to have 3 vanishing points. Parallel projection is a type of projection where instead of these lines crossing each other, the projection rays are always parallel to each other, so they never cross. And when you shine them to a projection plane, you're going to get a view like this. Where instead in the perspective projection, it would be a view where the distant parts of the object would look smaller. In real life, of course, you don't do that, but that's a handy method. And parallel projection is also divided into two: the orthographic projection and oblique projection. The orthographic projection is, or sometimes called the orthogonal projection, is a type of projection where the projection lines are always orthogonal to the projection plane. So this angle right here would always be 90 degrees. There are two different methods for orthographic projection. The first one is multi-view projection. Multi-view projection is basically applying this method to all of the different surfaces of the object. So front view, side view, top view, bottom view, left view. That is what multi-view projection is. As you can see here, front view, right view, and top view. And this multi-view projection is also divided into two. I don't think it's for an apparent reason, but I guess it's just a preference for some people. It's divided into two as the first angle projection and the third angle projection. In the third angle projection, you have the front view in the left corner. You can think of it as a center. The top view and the top of that, and the right side view at the right side of that. And if you want to add more, the left side view would be here and the bottom view would be here. And the back view would be under the bottom view. But in first angle projection, it's kind of the exact opposite. It's reversed. The front view is still at the center, but like the right top left of this view. And instead of the right side being on actually the right of this view, it's on the left of this view, and the top view is at the bottom of this view. So it's exactly reversed. And the symbol to define these projections are these. If when you're reading a schematic, if you're seeing this symbol, it means that it's drawn in a style of the first angle projection. And if you're seeing this symbol, it's drawn in the style of the third angle projection. We also have the front elevation and plan in multi-view projection, but they're not really multi-view. The front elevation is basically showing only the front view of the object, and the plan is basically showing only the top view of the object. So the second type of projection is the axonometric projection. And in axonometric projection, instead of picturing all of these sides one by one, the actual object is tilted for some angle. And since you've done this, now you can look at three sides at the same time. That's what axonometric projection is useful for. And there are three different types of it: isometric, dimetric, and trimetric. So in isometric projection, all of the angles of these projection axes are equal to each other. So since this is a 360 total, this is 120, 120, and 120 degrees. But in dimetric projection, the two angles between the two axes are equal to each other, while the third one is different. And as you can probably guess, in the trimetric projection, all of these angles between the axes are different from each other. So as you can guess, there can be multiple types of trimetric projections with all kinds of different angles in between. So, oblique projection. Other than orthogonal projection, we also have oblique projection. And the difference of oblique projection is that while one of the faces is parallel to the projection plane, the other faces are drawn at a different angle. But that angle is definitely not 90 degrees. Because if that was 90 degrees, there's nothing in here. There is no side view. You're just looking at a square at this point. So that's why the convenient angle is most likely 60 degrees, 45 degrees, or 30 degrees, dependent on the usage of this projection. If you have a cabinet type of oblique projection, you're going to see that the length of the front view of the projection is twice the length of the side view. It doesn't matter the degree of the side view. The only matter here is the length of these views. But in Cavalier projection, you're going to have the side view and the front view at the same length. And of course, to do that, this angle is going to be 45 degrees. So that was the end. A quick recap on projection methods.